Intermolecular force. Between molecules and molecules, there are an attraction force called intermolecular force. Student, I want to highlight one thing and watch. You may have heard of a word called intermolecular force and intramolecular force. Two words are different. The top one, intramolecular force, means the within. We're talking about within the molecule. That is the covalent bond, single or double bond, or ionic bond. That is within the molecule, called intramolecular force. But today, I'm going to talk about intermolecular force. Intermolecular force, which is between one molecule with another molecule, between one molecule with another molecule. So that is the topic, between intermolecular force, that we're going to talk. Intermolecular force, the attraction force between this molecule can divide into three big groups: hydrogen bond, dipole-dipole, and dispersion force. Hydrogen bond, they have a boiling point between 100 to 200 degrees. They have the strongest attraction. They have the strongest attraction in between the molecule. Dipole-dipole, they are the second. They are much weaker. The boiling point is between 0 degree to -100. So the attraction force between the molecules are weaker. The attraction force between the molecules is a lot weaker. Disperse force. Disperse force, they are even weaker. The boiling point is -200 to -300 degrees. And the attraction force between this molecule is even weaker. And now I'm going to demonstrate about these three types of intermolecular force. I use boiling to demonstrate. Boiling means vibration to the molecules and cause it from liquid turn into gas. And now we examine one by one. Start off with the dispersion force. On dispersion force, the boiling point is -200 degrees to -300 degrees. Means if I add tiny bit of a heat, slight tiny bit of heat means slight vibration of the molecule. When you have put vibration to the molecule, the attraction force between this molecule, will break. And when they break, because they're too weak to sustain, when they break, they turn into gas. This to demonstrate they have a very, very weak attraction. Now let's look on to the next. Dipole-dipole. The attraction force between this molecule also weak, but a little bit stronger than the early example. And this attraction, if I put vibration between 0 to -100 degrees, I raise temperature, cause more vibration. And now this attraction force cannot sustain that much vibration, and they tend to break. Again, this demonstrates that they have a very weak attraction between molecule and molecule. Hydrogen bond. Hydrogen bond is much stronger. And so between molecule and molecule, a very strong attraction. Between molecule and molecule, there is a very strong attraction. So I have to input a lot of heat vibration. When you have enough vibration of heat, and now this attraction force will break, and now it turns into gas. So in these three examples to demonstrate the attraction force between molecules of these three different types, hydrogen bond have the strongest attraction between molecules. Dipole-dipole have the medium attraction force between molecules. And disperse force have the weakest attraction force between the molecule. Student, you will think, how come some like hydrogen bond will have such strong attraction between the molecule, and some like disperse force will have such a weak attraction between the molecule? Why? Let's explain. You go back to your early topic, polar molecule. If you have the polar molecule like OH, NH, FH, you examine the electron negativities. They cause the molecule to be strongly positive one end, negative the other end. So when you have strong positive one end, negative the other end, you will have a strong attraction between the molecule. So it's just like a two strong magnet to attract to each other. So this causes strong attraction. It forms hydrogen bond. Dipole-dipole also is a polar molecule, but this time this polar is only partially positive one end and partially negative the other end, and the attraction force are weaker. So it's just like a smaller, weaker magnet, and they still can attract to each other, but the attraction force would not be as strong as the early example. Dipole-dipole is causing from the non-polar molecule. This non-polar molecule, the attraction force are very, very weak, but they still have some exist called dispersion force. So you can see this hydrogen bond, dipole-dipole, disperse force, they directly relate to your polarity of the molecule. Polar molecule cause hydrogen bond. Partial polar molecule cause dipole-dipole. Non-polar molecule cause dispersion force. Student, you have to learn this concept very well, and we're going to look at this in the future coming topic in more detail.